So today we move into a chapter called Quadratics, and with this chapter is a lot of review from freshman year, but this is where you guys typically had a lot of problems, so it'll be good review. So quadratic's basically a parabola. It comes in the form of ax squared plus bx plus c. That's said to be in what we call standard form, and there are other forms like y equals ax minus h squared plus k, which is vertex form, and we've dealt with that before. As far as the parent function goes, we know that's just y equals x squared. We can find the axis of symmetry by taking the opposite of the b term over 2 times the a term. The y-intercept is always going to be the c term because that's like setting x equal to 0. As you can see in the picture here, our vertex is the lowest point. If we had a parabola going upside down, like so, the vertex would be the highest point. Axis of symmetry splits that parabola equally. Now, a we've already talked about in our y equals ax minus h squared plus k form. Acts like our y multiplier and determines how wide or narrow the parabola is. If the absolute value of a is less than 1, this thing gets wider, and if it's greater than 1, it gets narrower. So a couple of things. We also know that if a is positive, we have a upwards opening parabola, and we call this lowest point, which is the vertex, a minimum value, and we state the minimum value by giving its y value, not its x value. Likewise, if we have an a value that's less than 0, then we know this vertex point is a minimum, and we give the minimum by its y value. And we move from there. If we take a look at a graph of a parabola and we want to state the vertex, the line of symmetry, the y-intercept, and whether we got a function or whether the function is a maximum or minimum, and then the domain and range are basically just explaining everything about this graph. We can pull off all that stuff from the graph. We've got a y-intercept here of 2. We've got a vertex of 2 and negative 2. We've got a line of symmetry going through this entire thing here of x equals 2 because it's a vertical line. Let's see, what else do we need? This is a lowest point, so we call it a minimum of, and we're going to use the y coordinate here, negative 2. Then we're going to state the domain in range of this. Well, notice the arrows go out forever, so the domain is all reals. And that's going to be the case for every single parabola because they'll open up forever. The range in this case, we're talking about the y values. Notice the y values don't go below this point, so y is greater than or equal to negative 2. And that answers everything there. So when we want to graph parabolas, there's a series of things we probably ought to do. First, you're going to find the x-coordinate of the vertex or the line of symmetry, and we've already talked about that. We take the opposite of b over 2a, and that gets us the x-coordinate of the vertex. Then to find the y-coordinate of the vertex, you're going to take and plug that right back in. So when we do that, we know we have a f of negative b over 2a. Finally, we find that a value, and that determines the shape. That's our y multiplier. Plug that into our pattern, and then we can graph from there. So let's do a couple. I want to find the vertex of this. So let's take and go the opposite of b over 2 times a. That gets me the x-coordinate of my vertex. So we're at a negative 1. And then I want Vy. I plug that negative 1 back in. That's negative 1 squared plus 2 times negative 1 minus 3 gives me 1, minus 2, minus 3, or in this case, negative 5. So I've got a vertex at negative 1, negative 5. Now, I see the a value in this case is 1. That determines the shape, so y equals 1x squared. We know what that looks like because that's just the parent function, 0, 0, 1, 1, 2, 4. And from that point, negative 5, or negative 1, negative 5 right down here, I go over 1 and up 1 in both directions, over 2 and up 4. And by using this method, I really never needed to plug actual values into the equation. I was just able to find the vertex and then use that pattern to graph the parabola. And that's kind of the approach we're going to use all day. So in this case, oops, let's go back because I forgot to find the domain and range here. And max and min. This has a minimum value. And the minimum value is the y value of negative 5. Domain, all real. Range, y greater than or equal to negative 5. Okay, let's move to that next example again. Again, negative b over 2a for v sub x. Negative 6 over 2 times 3 gives me negative 1. Dy is equal to 3 times negative 1 squared plus 6 times negative 1 minus 2. That's going to give us a positive 3, a negative 6, and a negative 2. We know, again, we have negative 5. Vertex isn't always going to be negative 1, negative 5. So I go to negative 1, negative 5. Put a dot there. In this case, a is equal to 3, so I have a pattern of y equals 3x squared, which means I take my parent function of 0, 0, 1, 1, 2, 4, and I take and multiply all my y values by 3, so I get 0, 3, and 12. And so from this vertex point, I go over 1 and up 3, and over 2 and up 12. And you'll notice this parabola is much skinnier than the one we previously did. Once again, the min, use my y coordinate of negative 5. I have a domain of all reals and a range of y is greater than or equal to negative 5. Bigger numbers, still not a problem. X coordinate is the opposite of 20 over 2 times negative 2, which gets me positive 5. Plug back into my y value. I get a negative 2 times 5 squared plus 20 times 5 minus 48, which is negative 2 times 25 plus 100 minus 48, or 50 minus 48, which is 2. So I have a vertex of 5 and 2. A value is negative 2, so I have y equals negative 2x squared. I take my parent function pattern of 0, 0, 1, 1, 2, 4, multiply the y values by negative 2, getting me 0, negative 2, and negative 8. So I go to 5 and 2 up, go over 1, down 2, and over 2, down 8. So you'll notice in this case, this has reflected. And rather than having a minimum, I have a maximum of the y value, which is 2. Domain is still all reals. And the range, in this case, is y now is less than or equal to 2. So let's hit a word problem. We've got a kid shooting an arrow up in the air. Height of the arrow is modeled by this equation. We want to know where y represents, or we know that y represents the height in feet, x seconds after it's shot into the air, and we want to graph this, and we want to find out at what height was the arrow shot. So basically that's at time 0. And what's the maximum height? So we're going to do this rather than, we could do this by going negative b over 2a. In fact, let's do that. What the heck? All right. First of all, we're going to find out what happens at time 0. When t equals 0, I plug that in, y equals negative 16 times 0 squared plus 100 times 0 plus 4. So that basically tells us the kid's 4 feet high. When we want to know what's the maximum height, well, all I have to do is find the vertex of this parabola. So x-coordinate of the vertex is negative b, negative 100, over 2 times negative 16, or 100 over 32. 4 goes into both of these. 25 times here, and 8 times here. So 25 over 8 is our x value, and then I'd have to plug 25 over 8 back in, and after getting on the calculator, I get 641 over 4. They want to know what is the maximum height when we set our maximums our y value. So that's going to be 641 over 4, which ends up being about 160.25 feet. Now, another way we can do that same problem is we can do this on the calculator. So if we get our calculator out and pop that guy up here and we graph this. So I want to graph this equation, negative 16x squared plus 100x plus 4. So I go negative 16x squared plus 100x plus 4. And I hit go ahead and graph on that. Take a look at what's going to happen. Parabola goes up and it comes down, but I never see the high point of it. So I'd have to adjust my window, and I know this is going at least 160 feet high. So, and one way you can kind of check this is take a stab at a couple numbers. If I just plug the number 1 in, I have negative 16 plus 100 plus 4. I'm already up at like 90, 80, right around there. So I'm going to go up to, let's say, 200 tall. Adjust that window, go to 200, and here I am. If I want to find that maximum value, we know how to find maximums. I go second, calculate, the maximum value, which is 4. I'm going to go to the left of that high point. Anywhere is fine. Then I want to go to the right of that high point. Anywhere is fine. And then hit enter. And there's my 160.25 height. So that's another nice way to get that done. All right, let's move on to the next problem. So, in this case, you've got a souvenir shop that sells 200 mugs at $6 each. The owner estimates that for every 50 cents increase in price. You're going to sell 10 fewer mugs, and we want to know how much your owner should charge to maximize the monthly income for the sales, and what is that monthly income. Let's just do this one on the calculator. First of all, if the guy's going to make money, he charges $6 for each mug. So therefore, his profit is calculated by taking the cash times every mug. So we know this guy's initially making $1,200. But he says, hey, if I take and increase my cost or increase what I charge, maybe I can make some more money, although I know I'm going to sell some fewer mugs. So he's going to say, well, every time I increase 50 cents. So how do I increase 50 cents? I add 0.5, but he may increase it by $1 or $1.50. So every 50 cent increment is X times. And he knows that if I go up 50 cents, then I cut 10 off my number sold. So I'd only sell 190. If I went up $1, I'm only going to sell 180. So basically, every time I go up X, I'm going to go down 10X in sales. So we want to find out what our maximum is for this. Again, let's go ahead and use that calculator. I'm not going to multiply this out. I could if I wanted to get it in a quadratic form. In fact, just for the heck of it, let's go ahead. That's 1200 minus 60x plus 100x minus 5x squared. So you can see this is 1200 plus 40x minus 5x squared equals y, which is our profit, which we're trying to maximize. So we know this is going to be some kind of parabola going down. So let's go ahead to our calculator, plug this in, and clear this out of here. We've got 1200 plus 40x. And I don't have to plug in the 40x. I could have plugged in this equation up here. Doesn't matter. Minus 5x squared. And let's see what happens if I can keep this window where it is. Go ahead and graph that. And unfortunately, I'm not seeing my parabola. All right. So I got to think about why is that? Well, again, if I go back to here and plug in the number 1, that's 1200 plus 40 minus 0. So I'm already up somewhere around 1200. So let's go up, and we're going to assume that he's going to sell, close to 200 cups. Maybe less, but close to 200. So now I'm going to increase my window. I'm going to go X to 200. I know he's probably not going to sell that because he's going to actually sell less because he's increasing his price. But we just said we're at least up at 1200 high, and he's hoping to make more than 1200. So I'm going to go to 1600 for my max height. This is how we kind of estimate what our window is going to be. And there's our new parabola. I think we overshot a little bit how much he's going to sell. All right, so let's go back to our window and make this a little smaller. All right, I'm going to go to, let's see, we're going to go to 50. And actually, X in this case is representing the number of 50-cent increases, so it's not how many he's actually selling. We'll talk about that in a second. Let's find the maximum here. Second, calculate maximum. Go to the left. That's left enough, I guess. Go to the right, enter a couple of times, and we end up getting basically 4 and 1280. So what this says with our x and y, 4 talks about the x value, right? And that's the number of 50-cent increases. Y in this case is the profit. So what this says is he does 4 50-cent increases. So he increases to $8 a cup. He's going to make $1,280. So he's going to increase $2 a cup and make $12.80. To find out the number of cups he sold, okay, all you really have to do is plug 4 into here, because this is the number of cups now. So number cups is going to equal 200 minus 10 times 4, or he sells a total of 160 cups. That's all we've got. Make sure you do your Connect Ed, and we'll see you tomorrow.